Fundamentals of graphing macroeconomic statistics. Economists rely heavily on graphics of actual data and to portray an economic theory in pictures. This discussion will provide the fundamentals of graphing data. The quote that appears on this page is by William Playfair, a name that few people probably know, but he is considered the father of infographics. Infographics, of course, are a very popular way to convey information today, through a mix of data, pictures, and shapes. In Playfair's 1801 book, The Commercial and Political Atlas, he begins the journey on what is today called infographics. Playfair stated in that book, quote, "As knowledge increases amongst mankind, and transactions multiply, it becomes more and more desirable to abbreviate and facilitate the modes of conveying information from one person to another, and from one individual to the many." Unquote. With this thought in mind, let's now begin our brief walk through the fundamentals of graphing economic data. This discussion is about the fundamentals and conventions used to graph economic concepts and relationships. You will see how to 1. Use different types of data and graphs. 2. Conventions for aggregate demand and supply graphs. 3. Graphing basic relationships between data. The first point to know is that there are three different types of economic data. 1. A scatter diagram is a graph of the value of one variable against the value of another. 2. A time series graph is a graph that measures time, years, quarters, months, etc., on the x-axis, and the variable, such as output or inflation, or any variable in which we are interested on the y-axis. 3. A cross-sectional graph is a graph that shows the values of an economic variable for different groups in a population, such as age groups or income groups, etc., at a point in time. An example of a scatter diagram is presented on this slide, which shows the relationship between the aggregate price level in the nation and real GDP or real gross domestic income, GDI. If you think of a table with two columns, one with the price level data, and one with the associated real GDP data, then those pairs of observations are also coordinates on the graph. An example of a time series graph is presented on this slide, which shows the relationship of productivity growth by decade. Here also, we have two columns of data. One column would be the time element, which is decades in this example, and the second column is the associated values of non-farm productivity. In this graph, those productivity growth and decade coordinates are plotted on the graph. A third type of economic data represent information only for a given or the same point in time. An example of a cross-sectional data graph is presented on this slide, which shows the U.S. Treasury interest rates for different durations for a point in time at February 2018. Okay, now that we have introduced you to the types of economic data, let's look at the conventions used to graph economic data in what is known as the XY space. It is referred to as the XY space because the horizontal line is the x-axis, and the vertical line is the y-axis. By convention, in both microeconomics and macroeconomics, the price term is plotted on the y-axis, and the output is plotted on the x-axis. Let's continue our discussion of scatter charts showing the relationship between aggregate prices and the nation's output. We will explore the basic relationships between these two economic measures. In this example, you see a blue line that is straight, and it is moving upward from left to right. The story that this represents is that there is a one-for-one relationship between price and output, that is, they move in lockstep, and that relationship is known as positive or direct, which means each variable moves in the same direction. This is the typical relationship between price and output of a supply curve, for example. In this example, you see the blue again moving upward from left to right, but the relationship is nonlinear, which means the price and output observations move at different speeds. Now, let's turn our attention to a price and output relationship that move in opposite directions, such as represented by a demand curve. This relationship depicted on the slide is linear, again meaning that the price and output observations move in lockstep with each other, but in opposite directions. In this example, you see that the price and output observations in both charts move in opposite directions from one another, which is portrayed by the downward slope in the blue lines. However, the left-hand chart has the relationship bellied out and the right-hand chart has the relationship bellied in, which is often how the demand curve is portrayed for economies of scale. Another type of graphic that is common in economics is to portray a threshold point between two variables. This is often shown using a parabola. That is a curve that resembles the letter U. Then the story that is told is that there is positive implication on one side of the U-shaped curve, and a negative implication on the other side of the U-shaped curve. One such example, as shown in the slide, is between the tax rates and tax revenues, which is known as the Laffer curve, and will be discussed later in this course. However, the argument is that there is some threshold point above which that the relationship between tax rates and revenues raised changes from a positive to a negative relationship. The textbook describes a couple of threshold models. Finally, let's consider two examples. The first is plotting a scatter diagram with real GDP and the GDP price index as shown in this table of data. Note that a scatter diagram with two variables will not use the year marker for the graphic, only the two variables of interest. Together these variables provide the XY coordinates for the graph. Then the first row of the table for the year 2016 provides the XY coordinates for the first point on the graph. The coordinate is 105.7 on the x-axis and 17,680.3 on the y-axis. This is highlighted on the graph. Following that pattern, can you tell what the price GDP coordinate is for the point A on the graph? Next, let's look at that same data, plotted as a time series. In this case, the x-axis becomes the time axis, and we can create the time series for either or both real GDP and the GDP price index. For this example, though, we will show the graph of real GDP only, but you should be able to do the time series plot for the GDP price index versus time. Here the first coordinate to plot is 2016 on the x-axis and 17,680.3 on the y-axis, as shown in the graph. What are the coordinates for point B on the graph? All of these data can be graphed in Excel, and when you get to the discussion of the aggregate demand and aggregate supply model, you will have a tutorial document on creating that model in Excel that builds upon these steps. Okay, this was a brief introduction to graphing. There are a ton of books available on the topic, but one recent one was published by the Financial Times, and noted on this slide, if you wish to explore the topic further. With this, we move on to a new topic.